Hey, Alex.
Hello?
Hey.
Oh, let me turn my volume up. Sorry about that.
Actually, you're fine on my end.
Oh, alright.
Yeah, I can hear you fine. Can you hear me okay?
Yeah, I can hear you okay now.
Okay. I got my camera turned off because it seems to be overloading GoToMeeting when I turn it on.
Oh.
Yeah, I don't know what's going on. But anyway, I got your documents.
Alright, cool.
3 of them, right?
Yeah.
Okay. Should we look at this number 1?
Yep.
These kind of problems are actually pretty easy. You just have to remember what to do. Whenever they give you the trig function and ask you about other trig functions, let's always start out by drawing a right triangle.
Right.
Label theta. That's the first one. Okay? Very important to label theta. So, if the cosine of theta is 2/3, how can I dimension this triangle?
If the cosine is 2/3, and the cosine is...
Cosine is what? Adjacent over...
hypotenuse.
Uh-huh. So I know that that has to be 2 and that has to be 3.
Next 3.
Well, if this is 2 and this is 3, what's this side over here? Because we have to finish dimensioning the entire triangle.
We do Pythagorean theorem.
Okay. So what's this side here?
9, 4, square root of 13.
This would be the square root of 5. Let's go over the Pythagorean theorem. When we're calculating one side, and
I know what
hypotenuse. If we're trying to figure out side A, then it's always the square root. No matter which side we're trying to figure out, it's always the square root of something. It always, the language starts out, it's the square root of, and in this case, it's c squared minus b squared. If you're solving for side B, it's the square root of c squared minus a squared. It's only when you're solving for the hypotenuse that it's the square root of a squared plus b squared.
Yeah, I don't know what I was thinking. I don't know what I was thinking.
So it would be the square root of 9 minus 4, square root of 5.
Okay.
Now that we know all 3 sides, what's the sine of theta?
So opposite over square root 5 over 3.
And the cotangent of theta?
Cotangent.
We can figure all 6 trig functions now that we know all 3 sides.
Let me get one sec. So it'd be shoot.
What's the tan of theta?
It's sine of theta over cosine of theta.
You should know what the tan of theta is all by itself. Here's theta, here's the triangle. What's the tan of theta? It's opposite over adjacent.
So the square root 5 over 2.
Cotan of theta is what relative to that?
Wait.
That was the tan of theta, square root of 5 over 2. So now what's the cotan of theta?
2 over square root 5.
Exactly. Now that does need to be rationalized. So that's 2 root 5 over 5. Okay. So in other words, once we get this triangle dimensioned, we can tell all 6 trig functions with no problem.
Okay.
Okay. Now the last thing they asked for was, what's theta? Well, if the cosine of theta equals over 3, how do I solve for theta? That is true if and only
I'm not
if,
sure.
well, it's important to understand inverse trig functions.
Yeah.
In
So
other
you just
words,
take the...
if I say the cosine of theta, and remember this is an angle, this is a number. If the cosine of some angle is equal to 2 over 3, then that angle is equal to the inverse cosine of the number. In other words, that's still an angle, that's a number now. So the argument of inverse trig functions is always a number, not an angle. And it always produces an angle.
Okay.
Another way to look at this is to take the inverse cosine of both sides. So I'm going to take the inverse cosine of the cosine of theta, and I'm going to take the inverse cosine of 2/3. Well, this is theta. So theta equals the inverse cosine of 2/3.
Okay.
Also equals the inverse sine of root 5 over 3. Because we had the sine of theta was root 5 over 3, which means theta is the inverse sine of root 5 over 3.
Okay.
Okay?
That makes sense. Just taking that.
That's what inverse functions are.
Okay.
It's attempting to find out the angle when given the trig value. All right, let's look at number 2. Okay, what's our first step?
Draw a 90-degree right triangle.
Okay, it doesn't matter how we draw it, as long as it's a right triangle. And, very important, we label theta.
Oh, yeah.
Now, dimension this for me.
Alright, what is it?
This side we'll call y, this call will fly. Okay. So what can I say? If the tan of theta equals 2, what does it say about y and x?
One sec. Opposite.
So if the tan of theta is equal to 2, how does that help me dimension the triangle?
It means that the opposite's going to be 2, and then the adjacent's going to be 1.
Now what's z?
And then it'd just be 2, wouldn't it? Also.
No, figure out based on the formula. Remember, c is the square root of 2 squared plus 1 squared.
So it would be
and it's plus because we're calculating the hypotenuse. Whenever you're calculating the hypotenuse, it's the sum of the squares of the other side. Whenever you're calculating a side, it's the hypotenuse squared minus the other side squared.
Yeah, so would it be square root 5 again?
Uh-huh. Okay, now let's answer their questions. What's the cosine of theta?
So the sine it'd be square root 5 over 2.
Cosine is what? Here's something you need to memorize. You don't want to have to think so long on these.
Yeah,
You want to know them like you know your name.
Okay.
Okay? So what's cosine?
Oh, Opposite of hypotenuse.
No, that's sine. Cosine is adjacent over hypotenuse.
Oh, so it'd be -5/1?
No, what's the adjacent side to theta?
1.
There's two of them. There's a 1 and there's the square root of 5. We always take the side of the triangle, not the hypotenuse. So 1 is the adjacent side to theta. So it's 1 over the hypotenuse. Rationalize that, and we get this. Okay?
Wait. Cosines...
Adjacent over hypotenuse. That's what this says. Adjacent over the hypotenuse. This says opposite over hypotenuse, and this is opposite over adjacent.
Okay.
Okay, so the next thing they want to know is what's the cosecant of theta?
Oh, okay. So that one would be negative, or not negative.
Cosecant.
Square root 5/2.
Good.
Okay. I was thinking cosine was the
Cosecant. Ah, I get you.
Yeah. I was getting those mixed up.
Okay. Let's go through them. We got sine, cosine, and tangent. What is each reciprocal? What's the reciprocal of sine?
Cosecant.
It's the reciprocal of cosine?
Sine?
No?
Or,
Here, let me give you a good way to memorize it. What's the reciprocal of tangent? Cotangent.
Okay.
Cotangent goes with tangent. So there's only two left. There's secant and cosecant. So we need to remember which one goes with sine and which one goes with cosine. Well, there's one co in each pair. So that's cosecant. There's the co in this pair. And the cosine is 1 over the secant. There's the co in that pair. There's the co in that pair. So if you start with the cotangent, or the tangent, when you do your reciprocals, you can always figure out which one of these goes with sine and which one goes with cosine.
Okay.
But this is something you also want to memorize.
Yeah. I definitely need to memorize that.
Well, even though this probably isn't the first time you've touched on trig, you probably did a little bit of geometry, right?
Yeah.
Yeah, the way the school system works is you do a little bit of trig in geometry, a little bit of trig in algebra 2, a little bit more, and finally you take the full trig course. Well, you're just partial, but I can tell you right now that you want to memorize this like you know your name, and you want to memorize those like you know your name.
Yeah.
Okay? So we've figured out cosine of theta and cosecant of theta. What's theta?
Cosine.
Starting with this. How do I solve for theta?
Take the
inverse, or arc. It's called either the inverse tangent or the arc tangent. That's how you read it. Inverse tan or arc tan. And your calculator has an inverse tangent button on it.
Yeah.
So you can look up the inverse tangent of 2 right now, and it'll give you an angle. So when you're solving for angles, just remember you have to do the inverse trig function.
Okay.
Okay? Everything else we solved for, we didn't. We just had to read it off the triangle. But when I'm solving for theta, the only way I have to solve for it is to look up the inverse tan of 2. Or I could look up the inverse sine of 2 over root 5. Or I could look up the inverse cosine of 1 over root 5. Any of those three will give me theta.
Okay. Yes. I don't know what I'm doing, but I just wasn't paying attention. That's exactly what we just did on the first problem, and I don't know what I was thinking.
All right. Okay. So let's see.
Taking
That's all.
the inverse.
Yes. The key is to solve for theta by taking the inverse. Okay. So that page. Let's look at this one. Yeah, let's see. If you can't read that, I'll read it for you. I can read it.
Oh, can you read that all right?
Yeah. Given the angle theta is minus 200 degrees, sketch it. First of all, how do I do negative angles?
What do you mean? Like, how do you?
Well, you do positive angles by going counterclockwise.
Yeah, you go the other way.
In other words, that's a positive.
Counterclockwise.
So you go clockwise to do negative angles.
Oh, yeah, clockwise. Yeah.
Okay. Starting from here. So I want to go around 200 degrees. Where does that put me? How far is it from there to there?
Negative 180.
Okay, so I got to go another 20, right?
Yeah. So it'd be like right there.
I basically have to do that. That's negative 200 degrees. The important thing is to get it in the right quadrant. This is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4.
Right.
Okay? List two angles, one positive and one negative, that are coterminal. She misspelled it. It's not conterminal. It's coterminal.
Oh, yeah.
With theta. So what positive angle? In other words, what is the measurement of this angle?
So it'd be 160.
160, is that what you said?
Yeah.
Okay, that's correct. So 160 is the same thing. Well, it's coterminal with minus 200. It leaves the ray in the same spot.
Yeah.
So all my trig functions of minus 200 are going to be the same as my trig functions of plus 160. What's a negative angle that is coterminal with theta?
Negative 560?
Yeah. In other words, if I go around twice to get to that spot, that would be 360 minus or plus a 200, so it'd be 560. Negative 560.
Oh, yeah, negative 560.
Negative 560, because they specified they wanted one positive and one negative.
Yeah.
Okay. All right. Let's look at number 4. Oh, I see. How do we convert radians to degrees? What's the conversion factor look like? It's either this or this.
It's the second one?
Well, it depends on whether you're going from radians to degrees or degrees to radians. In other words, sometimes it's either one of these. So the trick is to remember which one goes with what.
Yeah.
Now, it's not difficult. Just know that this is 180 degrees per pi radian. This is 2 pi over 3 radians. Since we're converting from radians to degrees, we want the radians to disappear and be left with degrees.
Oh, okay, that makes
That
sense.
becomes 120 degrees. If we started with, say, 90 degrees, and we wanted to convert that to radians, well, we need to multiply it by pi radians over 180 because we want to lose the degree and end up with a radian. So that gives
Okay.
pi over 2 radians. Now, you don't always use that. In other words, you don't see radians listed here. But in terms of how to convert it, it's useful to know that the radians almost always goes with the pi. In fact, you can just assume that for now, that the radians goes with the pi.
Okay.
Okay? So we converted 2 pi over 3 to 120 degrees. Now how about 3 pi over 4?
So we're going to
That's our conversion factor.
180 over pi. Boom.
Now, rather than multiply all these out, simplify it. Divide 4 into 180.
All right. Should be. Oh.
Pi's cancel. We got 3 times 45 is our answer. And that's the way you always want to do your math, incidentally. I notice a lot of people don't do this.
Yeah, I wouldn't have done that.
Well, you'd have probably multiplied 3 pi by 180 and then divided the whole thing by 4 pi. But always simplify, because I guess if you're using a calculator, it doesn't matter.
Yeah.
But you're not always going to be using calculators to do these.
Oh, yeah.
You're going to have tests where you can't use the calculator. And when you can't use the calculator, doing these simplifications really helps. Because otherwise, I'd have to divide 540 by 4, which is a harder calculation.
Oh, yeah.
Dividing 180 by 4. Okay?
All right.
And the last one there looks like minus pi over 2. Conversion factor?
It'd just be 180 over pi.
Doesn't matter whether it's negative or not. That's right.
Okay. And then would it just be 180 divided by 2 then? Oh, it'd be a negative though.
Minus 90 degrees.
Okay.
Okay?
It's not too bad.
No, it isn't. Once you get the hang
Really
of it.
easy.
Yeah. In fact, the ideal thing is if after a while you can start thinking in terms of radians. Probably a little soon for you to be doing that, but once you take the full trig course, which I presume will be next year, you'll want to get to a point where you just kind of think in radians. You know that 30 degrees is pi over 6. And let me give you a little bit of heads up on this. I have these memorized. Why? Because they're really easy to memorize. Notice that the product of this is always 180.
Oh, okay.
The denominator of the radian part is always multiplied by the other, as long as this coefficient is 1. And these are the biggies to memorize. Once you get those memorized, it'll help a lot. You won't have to use that conversion factor every time. And, of course, if 30 degrees is pi over 6, well, 120 degrees has to be 4 times that, right?
Yeah.
It's got to be 4 pi over 6 or 2 pi over 3. So it actually is pretty helpful if you do memorize these. And they're easy to memorize because of that fact that it's always 180.
Okay.
Okay. So what is 240 degrees? This one, let's go ahead and use the conversion factor.
All right, so it's going to be 240 times pi over 180.
Right, because we're losing the degrees.
And then
You'll notice that this is 60 will go into 180 3 times, and it'll go into 240 4 times. So So that's the same as 4 over 3 pi.
Oh, all right.
Okay?
240.
Yeah, 240 over 180 is the same as 4 over 3.
All right, cool.
Okay? All right, let's do
Just simplify. We're probably
30
I'll do
degrees.
one.
You remember what 30 degrees is, just from memory?
It's pi over 6.
Okay? And minus 135 degrees.
Alright, 1 second. Alright, it's going to be 1/8, or pi over 1/8. And then those.
It's a little bit harder to see this. Both of these are divisible by the number 45.
Okay.
So 45 goes into this 3 times. 45 goes into that 4
Yeah,
times.
4. Put it, and then it'll be negative.
Yes.
Alright.
Now, let me give you another way of doing this one, because it can be helpful. I just occurred to this other way. I mean, it just occurred to me now. If I have the small ones memorized, if I know that 45 degrees is pi over 4,
Uh-huh.
well, what multiple of 45 is 135?
3.
So it's got to be 3 pi over 4.
Okay.
So it could be
That is.
it could be easier to do it that way. It's certainly
Yeah, definitely.
Yeah, it's easier to see that 135 is an exact multiple of 45 than it is to reduce this. When you reduce this,
Yeah.
you have to see that 45 goes into both of them in equal amount. So it can be it can be useful having that little trick, as long as you have 30, 60, and 45 memorized.
Okay. I'll make sure I look at those and try to make sure I memorize those.
Okay.
For sure.
Let's see. Number 6. I do have to leave at 6:15 tonight. Apologize.
Okay.
Normally I can give you a little more time if we get started a little late. But I'm headed out of town tomorrow for 5 days, and I have been jammed up for the last 5 days with everybody trying to get a session in.
Oh, yeah. I bet. Are you going on vacation or?
Yeah, well, I'm going to a wedding, and I'm doing
Oh, nice.
road trip. It's in Sonoma, Arizona, so I'm leaving tomorrow morning. Yeah, I'm looking forward to it. It'll be a nice vacation, especially after the last 5 days.
Yeah, it'll be. Yeah. It's gonna be really nice there too.
Yes, it should. It'd be nice to get away from snow.
Yeah, I know.
Okay, we got a 22-foot extension ladder leaning against a building, making a 70-degree angle with the ground. How far up the building does the ladder reach? So the key part of this problem is to be able to draw it, because all it is a triangle problem. Okay, so there's my ladder leaning up against this building. Would
that mean it would be a right triangle?
Yes, because buildings are always built perpendicular to the ground.
Yeah.
So whenever it's a tree or a building or a mountain, it's a right triangle.
Okay.
What is 22 feet? Which part of this right triangle measures 22 feet?
The hypotenuse.
Okay. Where's the 70-degree angle?
In theta.
Which, lower left or upper right?
Oh, lower left.
Okay, so that's 70 degrees, because it says the ladder makes a 70-degree angle with the ground. So
Yeah.
not with the building, but with the ground. Okay, So they want to know how far up does the building, so they want to know this measurement y right there.
Okay.
What trig function will allow me to calculate y? What trig function of this angle involves the opposite and the hypotenuse?
It'd be sine.
So we have the sine of 70 degrees is
equals y over 22.
Which means y is equal to 22 times the sine of 70 degrees, which we get off of a calculator.
Yeah, I'll do that.
Yeah, we don't have a need to. As long as you know how to do it. We don't need to actually come up with numbers here. I mean, I know you do, but I think I've discovered a better technique of tutoring where I don't waste time getting answers. Because I've found that when I do, for 5 years I've been waiting and letting you get an answer here. But what happens is you then become focused on your calculator, and it's easy to lose sight of the principle. Whereas if we get it to this part and then go on to the next problem, which I think is the way to go, you can always go back and finish your homework after we're not in session. But it reinforces the concept much more effectively, is what I'm beginning to believe, if we do it the other way. So, close this one out, open this third one. Your hand was steadier on this one.
Yeah,
it's really critical to keep your hand steady when you take a picture of these things. I've found out that it's really hard. You know what I end up doing a lot is I take 2 pictures because I don't know which one is going to be steady. So when I'm scanning stuff to put into my computer, I'll just take 2 quick pictures and send both of them over and look at whichever one is clear. That's the one.
Yeah, I think I need to start taking my pictures upstairs because I always have that shadow and it blocks all the writing.
It's okay. In other words, this is as good as it gets. All I need to be able to do is read it.
Yeah.
And it's if you shake a little bit, then the letters end up being fuzzy, and it can be a little hard to read. But this is perfectly acceptable.
Cool.
Okay, so the height of Lincoln's caricature on Mount Rushmore. So there's Lincoln up there on Mount Rushmore. 2 sightings from the base of the mountain are taken. One from here and one from over here. Now, it's funny, I just had this problem with another student, a different take of it. If the angle of elevation to the bottom of Lincoln's face is 32 degrees, and the angle of elevation to the top is 35 degrees, what's the height of Lincoln's face?
Here, let me, 1 second. 32 degrees. So the top. So would I need to? That's 35 and that's 8.
This is a little tricky, but one of the very valuable parts of trig, which is how do you determine how high a mountain is? You can do it by simply taking 2 measurements like this. Let's look at the lower triangle, this triangle right here. What trig function relates these 2 sides?
That'd be the opposite. It should be tangent.
So I can say the tangent of 32 degrees is equal to h, is what we're trying to find, over x. Now use x because notice that x is the same for both of these triangles. The second triangle being this triangle. What can I say about the second triangle?
Well, it would be the tangent of 35 equals y over
The
y
opposite.
plus h over x.
Exactly. H plus y over x. I completely forgot one measurement here.
Oh, the 800 feet?
800 feet from the base of the mountain. So x is not
So
x,
that
it's
bottom part would be... Oh, okay, cool.
So I don't even need the bottom equation.
No.
H over 100. I mean H over 800.
Yeah.
That's a number. So H is equal to 800 times the tan of 32 degrees. Let's just leave it like that. That's to the bottom of his face. Now, their question is a little ambiguous, notice. They talk about the bottom of his face, and then they talk about the top of his face, and then they say, what's the height of his face? Well, I presume they mean H, to the bottom of his face. And that would be that.
Okay.
Okay? All right. What is sine squared plus... What's sine squared plus cosine squared?
Sine squared.
Yeah. Let's go back. Let's go back 1 second to this problem here. What if they meant to the middle of his face? Right there. Then we got to solve for y, right?
Yeah.
Okay, so let's solve for y. We know h now. H is this.
Wouldn't we...
What other function can I write regarding this big triangle? Tan of 35 equals what?
Can you just do the answer you get from h plus by y?
Plus what?
And then plus y?
Well, we don't know y. That's the thing.
Yeah, the answer from h plus by y, and then...
Right, but we don't know y, and we have to calculate y. And in order to calculate y, we have to say the tangent of 35 degrees is equal to h plus y. Well, we know h. H is 800 tan of 32 degrees plus y all over 800. Well, this is an equation we can solve. There's only one variable in that, y. This is a number, this is a number, that's a number.
Yeah.
So now when we solve for y, we know h and y. Let's say h is 160 feet. Let's say y is 40 feet. If they wanted the height of the middle of his face, it would be 180. If they wanted the height to the top of the face, it would be 200. And if they wanted the height to the bottom of the face, it would be 160. So that's the way the problem really should have been handled. I don't like this, what's the height of his face? I'm not sure what that means.
Yeah.
Okay.
Yeah, I don't know.
Any other questions about that problem?
No, that...
Okay.
Yeah, that's good.
Sine squared plus cosine squared. This is one of the Pythagorean identities that you want to remember. You'll get asked this on the ACT test also.
Okay.
One of the trig things you need to know. That's
I have it written down.
1. Always equal to 1, no matter what the it is.
Okay.
In other words, I could say the sine squared of 30 degrees plus the cosine squared of 30 degrees equals 1. could also say the sine squared of 77 degrees plus the cosine squared of 77 degrees equals 1 also.
Okay, so that's
So that identity right there, you want to memorize that. When you take trig, there's one more you'll want to memorize. But for now, that's all you need to know.
okay.
Okay? All right. I think that's everything that you sent me.
Yeah.
Do you have any more?
Yeah, that's all.
Do you want to read off? Or
Let me see if there's any.
we got 10
Last
minutes if you want.
Give me a second. Is there any chance that you could like make up a problem like 1 or 2?
Sure.
So we could like do another problem like that.
Like what?
Like if the tangent of theta is that, and then find the
I'll give you a similar problem. This is the
other trig
the
function.
classic height of a mountain problem.
Okay.
There's a mountain.
All right.
Yeah, let me draw it different. There's a mountain. You're coming in a wagon train rolling across from the east, and you see Pikes Peak. And you want to know how tall Pikes Peak is. So you take a reading with your little sextant, and this comes out to be 30 degrees. You then move 1,000 feet forward. And take another reading. This is a bigger angle. Let's say this is 40 degrees.
All right.
We have enough information by just moving 1,000 feet and taking 2 different readings. We can now tell how high that mountain is and how far away we are from it. And that's exactly what the first wagon trains would have done. They would have spotted Pikes Peak from about 100 miles away. They would have taken a reading on its height. They would have moved forward some distance, maybe 1,000 feet, maybe 100 feet, maybe a mile. And they would have taken another reading. Now, how can we calculate this? So I'm going to generate 2 equations and 2 unknowns. What's the first equation? Let's take the first triangle, the bigger one.
All right.
What can I say about the trig function that relates y and x?
So it would be tangent.
Tangent of 30 degrees. When you take a trig function, it always has to be followed by an angle, okay?
Okay.
Equals what?
Equals y over 100x or 1,000? Oh, it would just be x.
X being the entire distance.
Oh, okay.
The first sighting to the mountain. Now let's look at this triangle. What can I write?
Oh, you could do y over 1,000 minus x, or x minus 1,000.
Good. Now look at what we got. 2 equations, 2 unknowns. Only 2 unknowns. Means we can solve for both x and y. Now, just to make sure you can do that. So how are we going to solve this? These 2 equations and 2 unknowns?
We're showing how.
Let's solve one of them for y or x. So what's y equal to from the top one?
If you times by y equals tangent of 30, and then x.
Times x, right?
Yeah.
Okay, now we go down to this one and we substitute for y. In other words, we're going to use substitution.
Oh.
We're not going to use
Okay,
elimination, we're going to use substitution. So now we got the tan of 40 degrees equals, instead of y, I'm going to write tan of 30 degrees times x divided by x minus 1,000. Now we got one equation and only one unknown. Remember, this is a number, this is a number. So, what's the next step in solving this?
So it times x of tan 30, or x tan 30?
When you're solving an equation, the first thing you want to do is get rid of the denominators. How do I get rid of this denominator?
Oh, times it.
Both sides by it.
Yeah.
So we get tan of 40 times x minus 1,000 equals x tan of 30. Okay? Now what's the next step?
1,000 and then 10. Alright, and then I guess we just what would
distribute.
Just
at this
distribute.
point, yeah, we got to solve for x, but first of all, we got to get all the x's on one side and all the numbers on the other. So to distribute this, I multiply tan of 40 times x, so that's x tan of 40, minus 1,000 times tan of 40 equals x tan of 30. Well, now I gather all my terms with x on one side. So I would have x tan 40 minus x tan 30. Take this number, move it to the right side, it becomes 1,000 tan 40. I can factor an x out, leaving behind tan 40 minus tan 30.
Which should be...
Now I divide... No, let's not worry about... No, you can't do that. You can't just say that's not equal to the tan of 10. I don't care what that's equal to. I'm solving for x, so I'm going to divide both sides by that. Now we have x in terms of nothing but numbers. So x is equal to this. And then once we get x, we could go back and solve for y easy. Well, and the height of the mountain is y. So once we have a number for x, we can go back to this one and quite easily calculate y.
Yeah.
Okay?
Because then we'd have... Okay.
Yeah. So that's how they did it back in the 1800s when they came west.
Yeah, jeez. I think I just need to just go over these problems more, and I think I could get used to it pretty fast. Cause
I do too. This part of trig is not that hard. It really is just memorizing a few things.
Yeah.
And memorizing a couple of techniques. In other words, like that mountain. That's a difficult trig problem, incidentally. That's not an... I'm not sure you would really get that problem at this level trig. You might get it next year. But the mountain problem is a little tricky because it involves two equations and two unknowns. But all the others are very, very basic. It's just solving triangles,
Mm-hmm.
right triangles, and at that.
Yeah, it's easy.
Yeah. Okay. Let's end it.
Yeah.
And
Well, thank you.
I will talk to you next Wednesday night.
Yeah, sounds good. Thanks for the help, and have a good trip.
Thank you, Alex.
Yep. See ya.
Have a good weekend. Bye-bye.
Yeah.